Always appreciate yesterday, but work for a better tomorrow. So, hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. I welcome you all students to your Nexus Batch, and today we are going to proceed with our lecture number 3rd based upon the chapter Classification of Elements and Periodic Properties. So, I guess students, you have already revised the previous session and you have solved the homework questions also. So I was looking to your comment section and I feel so happy that you are attempting the homework questions that I have provided you. No need to worry, the solution for all the homework questions will be provided in the last lecture, okay, of this particular chapter. And you can just cross check over there, and then at that spot of time you have to write in the comment section that how many questions according to you were correct of yours, right? After matching mine, okay? After matching the answers from my end. So students, let us start with our today's session. Ma'am, what are we going to cover today? How are we going to proceed now with regard to the periodic table? I guess you all have learned the periodic table with the help of tricks. So students, my one recommendation is, if you have any easy trick in order to learn periodic table, you can write in the comment section, so the students who feel that this trick is much better than the previous one, they can remember that as well. So it depends only on you, okay? You can create the trick on your own in order to remember the periodic table, guys, okay? So now coming to my topic over here again, we are now starting with lecture number 3rd. And what are going to be the targets for this particular session? First of all, let us discuss that. So students, first of all, let me tell you that here we are going to do a nomenclature of the elements whose atomic number is more than 100. Okay, so we are going to name them particularly, and then afterwards we are going to see the classification and the prediction of elements, that they lie in which period, they lie in which group, they lie in which block. So we are going to do the prediction with the help of some certain rules. It's very easy, but yes, questions are asked. You will observe the question pattern over here in the session also. Yeah, so the third segment that we are going to start is going to be NCERT in-text question and the back questions. See, let me tell you about NCERT in-text questions, why I have taken this, and about back questions. I will be considering those questions which are like we need to solve something. The theory-based questions you can automatically just answer by your own with the help of notes that I am providing you, right? But there are some questions, for example, if I'll ask you just write the name for the atomic number 114th element, okay? So for that we are going to solve such kinds of questions, or if there is any numerical kind of question, we are going to solve that as well. Whether it is of NCERT in text or NCERT back exercise, we will be following that, but not the theory based, because theory based I know you can do by your own with the help of the notes that we are creating over here, right? So NCERT in text and back questions with regard to the topics till now we have covered, we are going to do that. And yes, there will be some homework questions also in between, in order to in order to see whether you are understanding the concept or not. And then is the question rounds, as we used to do in each and every session of ours, that we solve some kind of questions and then 3 questions as a homework, right? So now students, let us proceed with the very first topic of ours, but let us meet your friends, that is calcium and barium. So say students hi to calcium and barium. So basically they are saying, hello my shimmering stars, have you revised yesterday's class? If not, students, don't do this again, don't repeat this thing again. You need to revise it, just keep it in mind, but without revision you are going to forget it. At some instance of time you will forget whatever you have heard, whatever you have learned, if you're not revising it. For once everybody feels like, oh, we are getting the topic, we're able to understand it, we will rock in the examination. But for rocking in the examination, you need to practice, you need to revise again and again, again and again. Then only you are going to succeed. Without revision, you won't. For one instance of time, we feel like, yes, we are getting the topic. But if you are doing the revision, then only you will proceed. Then only it will retain in your mind. So do remember this, okay? Now here is barium. So he's saying, let's get ready for today's class. Yeah. So first topic is IUPAC nomenclature of elements whose atomic number is more than 100. Students, always remember, whensoever we are doing IUPAC of these elements over here, at the end we need to add EM, I-U-M-E-M. So let us see. The names are derived by using roots. For 3 digits, the atomic number of the elements, okay, and adding EM at the end, okay. Now the atomic numbers for the elements which have 3 digits in it, for them we are going to name it, and we have to add EM at the end. It's quite simple. Okay, let me show you the very basic rule that you need to keep in your mind. So this is the very basic rule that you have to observe it. So the very first thing is I have written digit over here. For example, I have provided you with 101. So these are digits 1, 0 and 1. So whensoever you see 1 over there, you have to write un over there. Okay. Whensoever you will see 0 over here, you have to write nil over there. Once you are observing 1 again, you have to write un. And at the end of that, you have to write ium, I-U-M. So by this way you're going to name it. So let me tell you for which digit, which word you have to use. Okay. So if you're using a digit 0 over here, students, if you're using digit 0, you have to write nil. Now the root is the word that you have to write is nil. But when you are, writing the symbol of that compound over here, the symbol of that element, you have to use the first initial letter, that is N. Okay, so you have to repeat after me. I know that it may sound very weird that ma'am we have to repeat it. You're not sitting in front of me. But yes, students, if you'll follow my instructions, let me tell you, it will be very, very easy for you about, understanding inorganic chemistry in order to understand it. So 0 is nil and N is your symbol. Then comes 1. For 1, you have to use un, UN. And the symbol you will be using is the first initial letter, that is U. Then comes 2, you have to use bi, B-I, bi, okay, over here. And then the initial letter B will be the symbol that we have to use. Then comes 3, that is tri, T-R-I, tri, and the initial letter is T, that is the symbol that you are going to use over here. Then comes what? Then comes 4, that is what? Quad, Q-U-A-D, quad, and you have to use Q as the symbol, the initial letter. Then for the digit 5, you have to use pent. The symbol is going to be the initial letter P. Then comes a hex. So you have to use the initial letter H. Then comes 7. For 7, you have to use sept. And the initial letter will be S, the symbol that you're going to use over here. Then comes oct. And for oct, that is 8 digit, you have to use O as the symbol. And at last is digit number 9. For that, you have to use E-double-N. Now, this is quite different. So, you can put a star so that you won't forget it again and again. See, why do we write stars or why do we underline certain things? For example, whenever you're having examination and you open your notebooks, if you'll observe a star or an underline symbol or something which is written from different pen, your initial, observation will go over there only. You will feel, oh, this is something important. First, I have to read this. That's why I've told you to put a star over here. For 9 digit, you have to use E-double-N and the symbol you're going to use is small letter E. Now, let us write one by one for all of them. Let us first write for 101 in order to make you more understand. So, 101, it is going to be, now for 1, it is un. For 0, it is nil. For 1, again, it is un. And at last, you have to write yum. How you're going to represent it? So, for 1, it is U. Then for 0, it is N. Then again for 1, it is U. So U and U. By this, we have to represent it. Okay, students. So now comes the nomenclature over here. Let me correct the heading over here. It's by chance written as Mendeleev's periodic table. So let me initially correct it. Everybody write down the names that you have just done with the help of digits over here in this column. Then I am going to write along with you. Yes. Start writing the names for 101, 102, 103 all over here, students. Yes, everybody. Start writing it. I guess everybody is writing. For 101, now only we have done. It is un, nil, un, yum. Un, nil, un, yum. Yes, everyone. Then for again 1, you have to write un. For 0, you have to write nil. For 2, what you have to write? By. See over here. It is written by. B-I, by. You'll be writing by. Then comes yum. Yes, now comes for 103. So it is un, nil, try, yum. Everybody write for 104, 105. I'm waiting for 2 more minutes and then we are going to cross check whether you have written right or wrong. Yes, everybody, write it down. Let us see for 104. It is going to be un, nil, quad now. For 4 we use quad, yum. And one more thing, students, please correct it over here. Here double I won't come. Only single I will come. So it is by yum. Yes? Shall we write for 105? Everybody. For fourth we use what? Quad. QUAD. Let us go for now fifth one. It is going to be un. Now for 0, it is nil. For 5, it is what? Pent. And then comes yum. Yes? Match your answers with mine. Then comes 106. So it is for 1, un. For 0, it is nil. For 6, what for 6 we are going to use? Hex. Then comes yum. Okay, for 107, what are we going to write? U, N, un. Then comes nil for 0. Then comes sept for 7. And then comes yum. Yes, everyone. Then for 108, it is for 1, it is again un. For 0, it is nil. Then for 8, it comes out to be oct. Then comes yum. Yes, for 109, what it will be? Un, nil, ENN, then comes yum. See, for 9 number, we have to use what? Ma'am, for 9 number, we have to use a ENN. Now, let us write the symbol of there as well. Symbols for there as well. See, for 101, this is the initial words which I am underlining over here so that it is quite clear to you. See, it is going to be UNU, then it will be UNB, then it will be UNT, then it will be UNQ, then it will be UNP, then it will be UNH, then it will be UNS, then it will be UNO, and it will be UNE. Yes, everyone. So these are the names which were further discovered and they were provided to it. That was for 101. In general, it is Mendelium. Then for 102, it is Nobelium. Then Laurentium, Rutherfordium, okay, Dubnium, Ceoborgnium. Now, one of the questions you will observe from this in NCERT in text as well. Then Bohrium, then comes Hasmium, then comes Meitnerium, okay. Clear, everyone? So these are the nomenclatures till 109. In the similar way, you have to do for 1010 to 1018. Shall we start? Yes, everybody, giving you 2 more seconds. Everybody do on your own. Then we are going to match your answers with mine. Yes, everyone. Shall I start now? So for 101, for 1 it is again un. For 1 it is again un. For 0 it is nil. Then comes yum. Then 111. So again for 1 it is un. Again for 1 it is un. For again 1 it is un. Then comes yum. Anium. Yeah. Then for 112 it is going to be un. Then again for 1 it is un. For 2 it is by. Then comes yum. Now comes for 113th. So it is going to be trium. Then for 114 it is quadium. Then for 115 it is going to be then pentium. Then for 116 it is going to be 𝐒𝐿. Then for 117 it is going to be septium. Then for 118 it comes out to be octium. Everybody kindly write it down so that we can move on to the next part of ours. Everybody kindly write this down. Everybody kindly write all of these names down so that we can move on to the next part. Shall we, students? Shall we? Okay, now let us write the symbols of them. So it is nil, un, unbuy, untry, unquad, unpent, unhex, unsept, unoct. Symbol is going to be OUN, oh sorry, UUN, not O, UUN, then it is UUU, then it is UUB, then it is UUT, then it is UUQ, then it is UUP, then it is UUH, then it is UUS, then it is UUO. Clear everyone? So these are the symbols for them. Yes everyone, so this was about the nomenclature. Now come students, the classification of elements as per S block, P block, D block, F block. I will come to this topic, but before that, first of all, do the prediction part. Let us do the prediction part. So how are you going to predict whether an element lies in the S block, P block, D block, or which period or group does it lies? Okay, so this is really very essential. See, for period, it is very simple. Okay, for period, what you have to see? The outermost shell. Outermost shell. The electron enters into which outermost shell? For example, let us take an example of nitrogen. Nitrogen has an atomic number 7. So it is going to be 1s2, 2s2, 2p3. Yes, that means what is the outermost shell over here? Ma'am, outermost shell is second shell. Second shell is the outermost shell. So that means the n value over here comes out to be 2. That means this is your period. So that means the period here comes out to be what? 2. Clear everyone? In the similar way, let us take few more examples. Let us consider magnesium. Magnesium has atomic number 12. So it is going to be 1s2, 2s2, 2p6. How many electrons? 2 plus 2, 4. 4 plus 6 is 10. 3s2, 12. So here outermost shell is your third shell. So n here is 3. That means period here comes out to be what? It comes out to be 3. Is it clear? So by this way, you can identify about period. You can tell clearly about period. Now what about block or what about the group? Let us first of all write here about block. Let us mention about block. See, if you have to see for block, you have to see that last electrons enters into which subshell. Very simple. That is basically the block. Okay. If last electron enters into S subshell, then it lies under S block. Quite easy, quite simple. If last electron enters into P subshell, so it is P block. If last electron enters into D subshell, so it is D block. Similarly into F, so it is F block. Clear? Let us take these examples only. Here last electron enters into P subshell, so this is P block. See, right? Here last electrons enter into S subshell, so it is S block. Clear, students? So this was about period and block. What about group, ma'am? What about group? Everybody first of all write this down, then we are going to do for group as well. Then we shall be doing for group as well. Everybody write it down, then we shall be doing for group as well. Everybody write in your copies. Yes, I hope so everyone has written this. Very good. You can pause the video and write it. Okay, students. Now comes for group. See, if it is S block element, okay, that means if last electron is entering into S subshell, then what you have to do? Then in that case, for group, see, total number of valence electrons. What I'm saying is, if you know that last electron enters into S subshell, that means it lies in the S block. So you have to see the total number of valence electrons. Let us consider the previous case only. That this is the S block element, right? So here last electron enters into S subshell. So calculate total valence electrons. Now, what are the total valence electrons? The outermost shell electrons. So over here, the outermost shell electrons are 2. That means this is the group number here comes out to be what? 2. Got my point? Very good. Take one more example over here. Let us take one more example of sodium. Sodium basically has atomic number 11. So it is 1s2, 2s2, 2p6, 3s1. Now see, it lies in the S block element, right? And how many valence electrons? 1 valence electrons. So group is first group. Because total number of valence electrons you have to see in S block case. So it is group number is first, right everyone? Now let us say for P block. Let us say for P block. See, in the case of P block, what you have to do is very easy. You have to calculate group as total valence electrons plus 10. Total valence electrons plus 10. Let us take the previous case only over here. In this previous case, what are the total valence electron? Outermost shell is second shell. It contains 2 plus 3, 5. 5 electrons. Now add 10 into it because it is P block ones, no? So 15th is going to be the group number. Group comes out to be 15th group. Is it easy? Is it clear to each and every one of you? Yes, everyone? Is it easy? Okay, let us take more cases. For example, let us consider for oxygen. Let us take an example for oxygen. Oxygen has atomic number 8. So you are going to write 1s2, 2s2, 2p6. Now see, 3s2, how many electrons? Sorry, I went above. Not 3s2. Here it will be 2 plus 2, 4. And 4 plus 4 will be 8. So it is 2s2, 2p4, right? It is 2s2, 2p4. This is the outermost shell. Now it is P block element because last electron enters into P1. So total valence electrons, that is 2 plus 4, 6. You will say, ma'am, why not 4? Why are you adding this 2? Because second shell is the outermost shell, no? So outermost shell is the valence shell. So second shell contains 2 electrons of S and 4 of P. So 6 plus 10. That means 16th group. This belongs to which? 16th group. Clear? Let us take few more examples. Let us take an example of carbon, atomic number 6. So this comes out to be 1s2, 2s2, 2p2. Yes? So now how many electrons in the outermost shell? 4. So 4 plus 10, this comes out to be 14th group. Clear everyone? So this was about P block. Let us talk about now D. About the D ones. That means when electron enters into, last electron enters into D subshell. For that case, group number is equivalent to number of total NS electrons plus total N minus 1 D electron. Okay. So by this way, you can find out the answer. Let us take the case of chromium, whose atomic number is 24. What is the atomic number of chromium, students? 24. So you have to write the electronic configuration. What will be the electronic configuration if you have to write for chromium? Yes, what will be the electronic configuration? It's very easy. It's very easy, students. It is going to be 4s2, 3d4 or 3d5. This was assumed to be electronic configuration. I guess you all have done this. This you have assumed to be electronic configuration, but it was not. The configuration was 4s1, 3d5. 4s1, 3d5. Yeah. So over here now observe. Now observe. Total ns electrons. N value is 4. N minus 1. 4 minus 1 is 3. So this is 3d electrons. This is ns electrons. So ns electrons is 1 plus n minus 1d electrons. That means 3d electron is 5. So this comes out to be what? 6th. That means it belongs to which group? It belongs to 6th group. Clear, everyone? This was assumed to be electronic configuration, but there was an exception. Electronic configuration, outermost electronic configuration came out to be 4s1 3d5. Here not outermost shell it is referred to as. It is referred as total ns electrons plus total n minus 1d electrons. Okay, now one question as a homework. Calculate for atomic number 29 and 30. The group in the chat section. Tell me their group, their block, their period. So this is question number first. Clear as a homework. Everybody write it down so that we can move on to the next part of ours. Everybody please write this down so that now we can move on to the next topic of ours. So students, let me give you one more question as a homework. That is question number 2. Calculate the same period, block, everything for Fe and for scandium. Okay, this is question number 2. Question first holds A and B part. Question second also holds A and B part. These are two your homework questions which I have provided you over here only. 2 homework questions, everybody, containing 2 part each. Clear? Now students, let us start about the classification of elements and the S block elements that we have already discussed in the previous class though. But now we will be doing this in detail. See, S block elements contains 2 groups, that is group number 1 and group number 2. Group number 1 and group number 2. Group number 1 contains your alkali metals. And group number 2 contains your alkaline earth metals. Okay. Let us talk about the, elements of this. So these are the elements of group number first. If I'll ask you the electronic configuration of all of them, it is going to be 1s1. It is going to be outermost 2s1. It is going to be 3s1. It is going to be 4s1. It is going to be 5s1. It is going to be 6s1 and then 7s1. These are the outermost electronic shell configurations. So if I'll ask you the outermost shell electronic configuration, it comes out to be ns1. For which case? For group number 1. Similarly for this one, okay, if I'll talk about this one over here, okay, then you can see the electronic configuration is going to be what? Over here, again, if you're going to start with, it is, I'm saying only outermost shell electronic configuration. Okay, so this is again outermost shell electronic configuration, which is basically ns2. So the general electronic configuration for S block elements, if I'll talk about, it is going to be ns1 to 2. This is the outermost configuration for this, right? And here n value indicates about period. To which period does it belongs? Or the number of shell does it have? For example, let us talk about the case of hydrogen. Hydrogen, this is the nucleus. This is your first shell. First shell contains 1 electron. Now for lithium, it is written 2s. That means it is first shell and then the second shell. And second shell contains 1 electron. Now for the case of sodium, this is your nucleus. This is your first shell, your second shell, and then your third shell. And third shell contains 1 electron. So by this way, you can clearly observe it. Right, now let us talk about its trend. See, basically it creates +1 and +2 ions over here. Okay. That means if I'll talk about group number 1, it will be like lithium plus 1, Na plus 1, K positive, in order to attain the stable electronic configuration. And they will obtain plus 2 electronic state, plus 2 ions over here, because they will lose 2 electrons, then they will become more stable. That means Ca plus 2, Mg plus 2. So they hold plus 2 charge, they hold plus 1 charge. Next thing is metallic character. Metallic character increases down the group. Metallic character increases down the group. That means when you are moving from top towards bottom, you will see that metallic character will increase. Okay. Moreover, S block elements lie at left hand side of periodic table. They contains metals over there. Moreover, as you can see, metallic character increases down the group, though I've already told you over here. Yes, students. And here, the last electron enters into S subshell. They have, students, high melting and boiling point as well, and they are soft in nature if you want to write down, and their size is also more. Size is also large. Everybody write down this about S block elements so that now I can start with about the next block, that is the P block elements. Let us see the next one now. I guess everybody has written this. Now starts with P block elements. So last electron enters into P subshell. Okay, let us talk about the P block elements. They lie from group number 13th to group number 18th. Yes, group number 13th is boron family, then is carbon family, group number 14, then is nitrogen family, group number 15, then is group number 16, oxygen family, then comes group number 17, the halogen family, and group number 18, the inert gases. Yes, moreover, non-metallic character increases when we move from left to right in a period. Left to right in a period. That means you are moving in this direction. So non-metallic character will increase. That means the P block ones will contain more non-metals. The P block 1 contains metals, non-metals, and metalloids. All of these three. But yes, non-metallic character will increase from left to right. Again, metallic character increases down the group. This was about P block elements. Let us discuss about the D block elements now. Let us everybody discuss about the D block elements. See, if I'll talk about the case of D block elements, last electron will enter into D subshell. Into D subshell. Or D orbital, you can even mention it over here. Now the next thing that you need to know over here in D block elements do contain, the elements from where you can observe that in the 6th period and the 7th period, there are 2 blocks which are kept separate. The lanthanoids and the actinoid series, which comes under the F block ones. So here you can mention F block ones contain 2 kinds of series, that is the lanthanoid one and the actinoid ones, which are just present beneath the D block one. They are present at the center of the periodic table. They are also called transition elements. They are basically the colored compounds, though there is an exception. There are exceptions. There are exceptions, students. Exception is the basically group number 12. Exception is group number 12 over there. Okay. They are colored complex. Okay. They do form salt. So this is about the D block. If I'll talk about the F block, let me tell you here, last electron will enter into D subshell. In other words, you can say it will enter into the penultimate shell. Penultimate shell. Why? Because we never write D. We always write N-1D. Like this. That's why. And over here in F block, when you will write, N-2F. So this is anti-penultimate shell. It is anti-penultimate shell. About F block 1. About F block 1. In F block, last electron will enter into F subshell. Quite clear, everybody? Everybody kindly write it down. Everybody, I guess everybody has written this. Now, this I have written all together. Let us talk about now metals and non-metals with the help of NCERT highlight only. What NCERT says, whatsoever we have studied, we will read it. So according to NCERT, metal comprises more than 78% of all non-elements and of all non, this is not the, another non-metallic one. I'm saying all the non-elements that we know. And basically they are present on the left-hand side of the periodic table. That means the S block elements, if we'll talk about metals, okay? Metals are usually solid at room temperature. Very important thing. Very important thing. Metals are usually solid at room temperature. But yes, there is an exception, which is mercury is an exception over here. And gallium and cesium also have very low melting points. Though I've already told you when I was writing in S block elements that they do have high melting and boiling point. But yes, there are more exceptions, such as gallium and cesium. They have very low melting point over there. So this is also an exception. So see, NCERT highlight with regard to metals, non-metals and metalloids are really very important. So I have written over here, everybody please kindly mark in your NCERT these important key points. Metal comprises 78% of which they are present on the left hand side. And yes, metals basically, if I'll talk over here about the melting point and boiling point, they are high. But exception is in gallium and cesium. Moreover, they are solid at room temperature, but mercury is an exception. Next, metals have high melting boiling point, already told you. They are good conductors of heat and electricity. They are malleable and they are ductile. That means they can be hammered into thin sheets and thin wires respectively. Yes, everyone, malleability and ductility you have studied in your class 10 standard as well. So this was about the metals as per NCERT. Let us read about non-metals. Again, this is yet important NCERT highlight. So non-metals are located at the top. Okay, they are located at the top right hand side of the periodic table. That means the P block elements, right? If you'll see, this is your, let me show you it over here only. If this is your periodic table, students, these are your metals and these are your non-metals that you can clearly see. The ones that are present on the right hand side. They have mentioned it over here. Metals are this one. These are your non-metals. Okay. And other one, they have shown you the transition elements that are the D block elements. Okay, let us come back to this topic. Non-metals are located at the top right hand side of the periodic table. In fact, a horizontal row, the property of element changes from metallic on the left to non-metallic on the right. I already told you that non-metallic character increases when you move from left to right. When you move from left to right, so the non-metallic character will increase over there. Non-metals are usually solids or gaseous at room temperature. Metals were solid, but yes, they are solid or gaseous at room temperature. And they do have low melting and boiling point, but yes, boron and carbon have high melting and boiling point. So this is again an exception. Do remember in the previous case, mercury, gallium, cesium, 3 exceptions. Mercury had of the state and the melting point case was for gallium and cesium. Over here again, melting point case is for boron and carbon, which have high melting and boiling point, though the non-metals do have low. Okay, so they are poor conductor of heat and electricity. Most non-metallic solids are brittle and they are neither malleable nor ductile. Clear, everyone? Now students, let us see about the third one, that are metalloids. Let us start with them. Now, the elements become more metallic as we go down a group. I already told you metallic character, it will increase down the group. So the non-metallic character increases as one goes from left to right across the period, but from top to bottom, metallic character will increase, right? The change from metallic to non-metallic character is not abrupt as shown by the thick zigzag line. Okay, the elements, now they have told you which elements: silicon, germanium, arsenic, antimony, and tellurium, even polonium. Okay, bordering this line and running diagonally across the periodic table shows the property that they are characteristic both metals and non-metals. They contain both of the characteristics of metals and non-metals. That's why they are referred to as metalloids. So what are they called? Ma'am, these elements are called semi-metals or metalloids. Clear, everyone? Kindly mention this in your NCERT, my dear students. Clear, everyone? That's great. Now, students, comes the very first NCERT in-text question. Let us start this. Okay, now comes, what would be the IUPAC name and the symbol for the element with atomic number 120? See, I've already told you, students, we will be doing the topics. Now, let me tell you, I'm not, taking topics in a larger amount. Why? Because now only you have started your class 11th. Until now, till class 10th, you were at a space where you used to learn things, but now you are at a space where you have to understand things, right? So I'm going to create a habit of yours of understanding topic, very few topic, then a bit more, then a bit more, then a bit more. Similar way, if you have observed in the first lecture, we have done very few questions, then in second lecture more questions, now in third lecture more questions will come, in next more questions will come. So by one, step by step, I'm going to create your habit. Not at a certain, I will provide you so many questions, you will be like, oh my god, ma'am, this is so hectic, this is so, we are feeling so stressed out. No, not at all. You will feel chemistry when you are going to study. You have to feel chemistry, you have to understand chemistry, that's it. So now one by one, topic by topic in detail, I'm explaining you with NCERT highlights so that you'll be able to understand each and everything properly. Let us see the NCERT in-text question. That means the questions that are provided after topic to topic if you're going to read NCERT. So problem 3.1 is that one. What would be the IUPAC name and symbol for the element with atomic number 120? So for 1 you use un, for 2 you use bi, and for 0 you use nil, and at the end you have to use em. So how you're going to do? It is un plus bi plus nil plus em. So it is going to be un bi nilium. What will be the symbol? UBN. UBN. Easy, easy. Okay, shall we move on to the next question? Everybody has written this? Very good. Now comes the next question. Now students, one homework question. This is third question as your homework. 2 questions I have already given you. See, one nomenclature question of NCERT in-text we have done. Now next is for you. The elements with atomic number 117 and 120 have not been yet discovered. Okay. In which family group would you place these elements, and also give the electronic configuration in each case? Very interesting question. The prediction question, the electronic configuration question, the nomenclature question, all questions in a certain question. Yeah. So this is question number 3rd as a homework. You have to write the answer in the comment section. No need to worry. We will be discussing each and every homework question at the last lecture of the chapter. Now many of you may think that, ma'am, when we are going to discuss, we'll solve at that spot of time. Don't do that thing, students. Do the things which I say you directly. If I say you read it right now, read it right now. If I'm saying solve it right now, solve it right now. Because your aim is not very small. If you have dreamed a very big dream and you think that yes, you have to achieve something in life, students, for that you need to do hard work. And now only you've started studying class 11th. It's initial start. So if you are very confident from the start, if you are doing hard work from the start, it won't create a mess up at the end. Okay, it will be very sorted. But if you are skipping the things over here now, it will affect you at the end of the the examination, when examination would be approaching. So this is question number 3rd as a homework. Let us read the next question, problem number 3.4. Oh my god, now yet again the most interesting one. So this is again as a homework. Why? Because I have already told you the trend. I will write the trend over here, but answer you have to tell me. So this is question number 4th as a homework, problem 3.4. Considering the atomic number and the position on the periodic table, arrange the following elements in the increasing order of metallic character. So metallic character is quite easy, no? Metallic character, see. Metallic character, if you will see down the group, it is going to increase. And across a period, metallic character will decrease, non-metallic character will increase. Non-metallic character from left to right is increasing, but metallic from left to right is decreasing. So now arrange them and write the order in the comment section. This is your question number 4 as a homework. Everybody write it down. I'm getting a side so that you can write it down. And we can move on to the next question of ours. Shall we, students? Everybody written this. This is again your NCERT in text question I am here talking about. Okay, let us see the next one now. Next comes your NCERT back exercise. Now, 3.1 and 3.2 question are theoretical questions, so no need to solve it out. You can read it. It's very easy. You can see the answer in the notes. 3.3 question is, what is the basic difference in approach between Mendeleev's periodic law and the modern periodic law? So students, Mendeleev's periodic law, basically it put emphasis on the thing that physical and chemical properties of elements are a periodic function of atomic mass. That means when you are going to arrange elements, you are going to arrange in order of increasing atomic mass. But modern periodic law faced emphasis on atomic number, not atomic mass. So this is the huge difference that you are going to observe. Let us see the next question. Next is 3.5 question. In terms of period and group, where would you locate the element with Z is equals to 114? Yes, students, where you are going to locate the element 114. So you very well know the answer, because yes, we have done the periodic table. Now only we have done the prediction section. So this is question number 5 as your homework. See, I want you all to practice as many as questions as you can. See, I will be solving questions over here, but until and unless you won't be able to do it, you won't try to solve it, you won't get it. More the questions you practice, more the concept becomes clearer, right? This is question number 5. Next, write the atomic number of the element present in the third period and the 17th group of the periodic table. 17th group. So what are 17th group elements, if you remember? Yes, anybody? So this lies under second period, this lie under third period, this lie under the fourth, and this under the fifth. So third period, 17th group is chlorine. Chlorine basically, ma'am. Chlorine is your element. So if you don't know the atomic number, what you have to do, you have to add 8 into it, you will get the atomic number, that is 17, the magic numbers. The atomic number is 17. Clear? 8, 18, 18, 32. Yes. Okay, students, moving on to the next question. This was 3.6. Now comes 3.7. Which element do you think would have been named by Lawrence Berkeley Laboratory and Seaborg's group? Now see, I will show you these elements. You will get your answer in the periodic table. Let me show you. See, really sorry, students. See over here, Seaborgium. So Seaborgium basically has an atomic number 106. This we have already done. In the similar way, you have to tell about the another one. See, Lawrence, so Lawrencium 103. 103 and 106. So 103 and 106. Clear? Easy question. So this was 3.7 question. Now students, here are few more tricks of the period number 6th and period number 7. So I have told you to create your own trick, but yes, I have brought for you people as well. So period number 6 starts from the element 57 and it ends at 80. But over here there is a very simple basic difference that after 57th element you will be seeing 72 element, because in between elements are your lanthanoid series, right? From 58 to 71 they are the F block elements, so not placed over here. 57th is lanthanum, then 72 is hafnium, then is tantalum, tungsten, rhenium, osmium, iridium, platinum, gold and mercury. So what is the trick in order to remember them? That is lady for lanthanum, have fun for HF, then is for traveling it is Ta, tantalum, then for world it is tungsten. See, tungsten is starts from T, but yes, the symbol is W. So world is tungsten, then and is an extra word underlining it. Rhenium is the reach, RE. From osmium I have written out. For IR I have written India, and then for PT I have written please. AU I have written ask. Now don't consider that it is gold, so you have to start with G. No, I am representing symbol. And then her, it is mercury. Now mercury starts with M, but the symbol is HG. So the trick is, lady have fun traveling and reach out India. Please ask her. Okay. So this is for the period number 6th. Now comes for period number 7th. So it is basically again the same trend. After 89, you shall be observing elements in the your another series, that is actinoid series, and then comes 104. So we have actinium, rutherfordium, dubnium, ceoborgium. Now only we have done SG 106 right? And then comes bohrium, hassium, meterium. Okay, then these are the elements. These are more than 100 ones. So more than 100 ones we have already done the nomenclature, right guys? So basically it is act really dynamic, so the best has met. This is going to be the trick for this period. Clear everyone? Act really dynamic, so the best has met. Clear? So these tricks I have already told you. Now I don't know whether you have done the homework question or not. Create a trick for lanthanoids and actinoids. When we are going to study about lanthanoids and actinoids in detail, I will be telling you their tricks. So you have to create a trick for this as well. This is question number 6 as a homework, creating trick for lanthanoids and actinoids. So now calcium says, hi barium, let's practice some questions. And barium says, yes, I'm ready. Are you ready, my shimmering stars? Okay. So here comes the very first question of ours. The third alkaline earth metal ion contains number of electrons and protons as. Now, alkaline earth metals basically refers to your group number 2nd, ma'am. Now, what were the elements? So, this is the 3rd member. That is calcium. That is what is calcium. Calcium has an atomic number of 20. So, calcium is atomic number 20. But I have told you that it creates +2 charge on it. Like this. So, 20 is Z, that means it is number of protons. But how much will be electrons? 20. If it is written +2, you have to -2. If it is written -2, then you have to add it. So this comes out to be 18 electrons. So 20 protons and 18 electrons. That means option number C is going to be the correct answer for this particular question. Clear everyone? Write down the answer so that I can move on to the next question of yours. Everybody done? Okay, next question is, a metal having electronic configuration is in which block? So in order to see the block, you need to see that to which basically last electron enters. So obviously just see over here, it is going to be first of all 4s/3d10. Last electron enters into D subshell, not an S. Don't get confused. When you're doing the electronic configuration, when you're writing the electronic configuration, first of all you will write 4s2, then it will be 3d10, which is basically zinc. This is basically zinc and it lies under D block elements. So answer is going to be option number B. If you are getting confused, write down the electronic configuration, the atomic number for zinc as 30 and then start writing it. It will be 3D, it will be 4s2 3d10. So last electron enters into D subshell, students. Clear? Let us see the next question now. The element having atomic number 33 lies in the group. Element with atomic number 33 lies under which group? So, nitrogen has an atomic number 7. You will add 8. You will get, 15. Then you will add 18. You will get what? 33. So, arsenic is the one which has an atomic number 33. You will say, ma'am, how do you know it lies under nitrogen family? So, this is done by practice. If you'll practice more and more questions, you'll get the answer. Or what you can do is write the electronic configuration. If you don't want to write like this, write the electronic configuration, you'll get your answer. So it is basically arsenic. To which group it lies? It lies under the 15th group. Nitrogen is 15th group. So answer comes out to be option number C. Clear, everyone? Everybody please write it down so that we can move on to the next question of ours. Yes, students. Done. Okay. Now comes the next question. What will be the IUPAC name of the element having Z is equals to 106? See, for 1 it is un. For 0 it is nil. For 6 it is hex. And at last you have to write eum. So it is going to be un-nil hexium. Let us check. It is quadium 104, heptium not possible. See, unhexium not possible. It is 116, but it is 106. So B option is going to be the right answer for this particular case. Clear, everyone? Shall I move on to the next question, students? Okay, let us see the next question. An element has electronic configuration this. Predict the period, group and the block. See now, last electron enters into P. So the block is P block. Block is P block, P block. These two are wrong. Now, next part is predict the group and the period. See, N value is 3. Period is third. Period is third. Period is third. Now, let us see the group. How are you going to see the group? Last electron enters into the P1. So, in the case of P, how do you go for it? In the case of P, total valence electrons is 2 plus 4, 6. 6 plus 10 is 16. So, answer comes out to be A option. Group number is 16. Answer comes out to be A option. Clear, everyone? Shall I move on to the next question? Next question is, an element with atomic number 36 belongs to dash block in the periodic table. So, you very well know the 36 belongs to which? Ma'am, D block. 36 elements lie under the group number 18. Quite easy. So not D block, sorry. sorry. P block. Group number 18, right? So answer comes out to be A option. D block are the one which are present at the center. P block are on the right hand side. Yeah, so it is P block, group number 18. Answer comes out to be option number A. An element with atomic number 21 is a yes, everybody. Now this, I will let you know what is the element's name. Element's name is scandium. You have to tell me the answer. This is question number 7th as your homework. Question number 7th as your homework. Clear? Okay, students. Now few more homework questions for you. Question number 8 as your homework is, in the long form of periodic table, all the non-metals are placed under which block? Okay, clear? You can pause the video, see the question. Moving on to the question number 9th. Question 9th is, which is a metalloid? That means which holds both the properties of metals and non-metals. So you have 4 options over here. This is your question number 9th. Then comes your last question, question number 10th. That is, an element with atomic number 55 belongs to which block? 55. Clear? So thank you so much, my dear students. This was all about today's session. I hope so you enjoyed today's class a lot. Now we will be meeting in the next class. Next class, let me tell you, is going to be very, very important with regard to your examinations. Don't skip it out. So let us meet in the next class. Till then, keep smiling, keep learning. Thank you so much and take care, my dear students.